The military port of Toulon. For the last 10 months, the Charles de Gaulle has been in dry dock. The objective of this technical stoppage is to carry out a major overhaul after years of operational service at sea. In 10 months, the ship has already been extensively emptied and dismantled. This challenge has been taken on by the sailors and the team from Naval Group, the contractor overseeing this extraordinary work.
This aircraft carrier is a runway sitting on top of 2 nuclear reactors and an armory filled with several hundred tons of weapons. It's a city with around 2,000 inhabitants. It's a concentration of technology, but also a concentration of knowledge.
The second phase of the work begins. It will last 8 months. The priority now is to adapt and modernize the ship, to transform it so that it can face the challenges of the 21st century and keep this nuclear aircraft carrier amongst the world's elite.
The technology which we're putting in place today in a certain number of areas is undoubtedly the best in the world.
You will discover the transformation of this exceptional ship. The renovation of the Combat Information Center, the nerve center of the ship, the replacement of the radars, but also the work to the landing and catapult systems, and the new configurations of the Rafale hangars. One major challenge during this work is to move to 100% Rafale, replacing the Super Étendard, which previously made up part of the carrier-borne fleet, with Rafales. These French fighter jets are perfectly adapted to the challenges of tomorrow's warfare. The change to 100% Rafale will simplify cooperation with allies. You will witness the sailors' training, tireless work to get to grips with the new technology being fitted. The objective is to be ready on the big day in 8 months' time, when the ship will take to the seas once more. Welcome backstage on the aircraft carrier of the future. The challenge behind this work is considerable. Since the Charles de Gaulle was built at the end of the 1980s, technology and combat has evolved enormously. Everything needs rethinking, replacing, modernizing.
This ship will be able to see better, understand better, react better.
A crazy undertaking requiring a total of 18 months' work.
This overhaul represents 4 million hours of work, 160 partners, and 200,000 work tasks.
The teams pass the baton continuously, day and night, and I mean day and night. Each has their sprint to run, which all add up to a marathon.
For the French Navy, the stakes are both technological and political. The Charles de Gaulle is the only French aircraft carrier. Without it, French power is diminished. Like each week, the Pasha, better known as the captain of the Charles de Gaulle, Antoine de Saint-Germain, supervises the work. The sailors of the aircraft carrier work alongside the teams from Naval Group, the sole contractor overseeing this exceptional work.
So, give me the lowdown.
The plating is thick enough, and it's going to be painted.
The know-how of our sailors is a reflection of French excellence in a certain number of domains, notably in terms of technology.
In the bowels of the aircraft carrier are thousands of rooms and cupboards to be optimized, enlarged and transformed. The captain verifies that they will be well adapted to his crew. The captain's tour ends in the Combat Information Center, or CIC. All military operations converge on this spot. This is the nerve center of the aircraft carrier. It's well protected, several floors beneath deck. Weapons, radars, inter-vessel information sharing. This is where dedicated computers, called calculators, centralize the ship's sensitive information. When in the theatre of operations, sailors need to be able to analyse multiple parameters as quickly as possible. An impossible task without the CIC.
It's within the Combat Information Center, at the strategic heart and nerve center of the ship itself, that all this coordination work is done.
It's basically the brain of the ship, software which brings together all this information, which may be coming from American vessels or which can equally be supplied to American vessels.
The calculator is an indispensable element for the ship's self-defense. This is where a threat is evaluated, allowing the captain to decide, if necessary, to fire upon and destroy a threat to the aircraft carrier.
In a world where events can turn around from one second to the next, modernization of the Combat Information Center is a priority. To allow the Charles de Gaulle to cope with future threats, an enormous technological leap is in progress. A gigantic surgical operation. The consoles, the furniture, and the operator posts are ripped out. From the false ceilings to the floorboards, everything is removed, planed, stripped. This ship will be fitted with the very latest equipment. The challenge is to confront the conflicts of the 21st century.
We've moved from the age of copper to the age of fiber optics. External communications are now broadband.
A stage which required unimaginable lengths of cabling to be replaced by fiber optics.
Here you have a technical cabinet, which is typical of the material on board, with active equipment working as an exchange system for onboard communications, and the cabling which connects the whole ship.
The figures behind these installations are impressive. In all, the equivalent of 340 kilometers of copper cable and fiber optics are fitted.
Let's test it, Sam.
Perhaps you can see if there's a nozzle underneath?
There are bays underneath.
Right.
The new equipment fitted in the CIC is the fruit of years of reflection. These new systems which are installed are extremely high speed. They need to be able to overcome a new threat, hacking and cyber attacks.
The procedures for being able to interact with the ship's computer system have been completely tightened since the modernization began. Today, you can't come on board with a USB drive or a PC without authorization from the computer safety officer. Any such material systematically goes through antivirus checking.
To defy these new threats, the systems have been completely rethought. Computers, screens, and the software are changed. Information access and speed of exchange with allies are pivotal for staying at the forefront of the world's elite.
Your screen immediately displays what you need to know about the working zones according to their size. The system itself isn't complicated. It's more intuitive than what we had before.
These new communication networks will allow the Charles de Gaulle to stay on top of future military operations. It shouldn't be forgotten that the Charles de Gaulle is above all a floating airport. It would be nothing without its aircraft, its carrier-borne fighters. They are what give the ship its phenomenal striking force. Air defense, ground or sea attack, aerial support for ground troops, reconnaissance. Thanks to them, no conflict zone can escape the French aircraft carrier. But to improve the performance of the Charles de Gaulle, a drastic choice has been made. While the previous fleet was composed of Rafales and Super Étendards, from now on all the fighter aircraft on board will be Marine Rafale F-3s.
The change to 100% Rafale will have two advantages. Firstly, the organization of maintenance on board by having only one type of aircraft is far easier. Setting up a flight plan becomes simpler for everyone involved, from the drawing board to the flight deck. The second advantage is the military capacities available with the Rafale compared to the Super Étendard are vastly superior. Consequently, a flotilla of just Rafales gives us an increase in overall military effectiveness.
The replacement of Super Étendards by Rafales is a revolution. With the latest marine Rafales, the aircraft carrier and its aircraft take on a new dimension. The capacities of the Rafale are exceptional. It can fly almost 2,000 kilometers without refueling, with a top speed of 2,400 kilometers per hour. Its twin engines mean that in case of breakdown or damage, the aircraft keeps flying. A hook attached to the forward landing gear allows for catapulting the marine Rafale. Its weapon capacity is impressive. From standard missiles to atomic bombs, it carries 3 times as much equipment as its predecessor. The marine Rafale has another singularity designed for the aircraft carrier, a tailhook allowing it to catch the braking cables during the landing phase. Power, speed, agility. Never has the aircraft carrier performed so well.
You arrive at the theater of operations. You connect up with the entire technical environment, and you're capable of going into combat.
Marine Rafale pilots receive very specific training. They need to learn how to land on the equivalent of a tennis court. Decelerate from 240 kilometers per hour to standstill in less than 80 meters. To achieve this type of landing, the ship is equipped with what is known as a resting gear, enormous cables which stretch across the deck. Naturally, they are checked during the overhaul.
It all happens very quickly on board. You feel the deceleration a bit like when you stamp on the brakes on a highway. Basically, you go from 250 kilometers per hour to 0 in 50 to 60 meters. There's a metallic screech. That's something I remember from my first landing. I had the impression that I'd exploded both my tires and was driving on the hubs, because the sound of metal was incredible.
If the Rafale doesn't catch the arresting gear, it immediately takes off again. In the theater of operations, there's no time for relaxing. The sailors and pilots must be prepared for a takeoff at any moment. To ensure such efficiency, the catapult system is entirely renewed. The catapults. This is the launching system for the marine Rafales. Underground rams propel the aircraft in a straight line along a rail. Hidden from view, they are positioned beneath the deck of the ship. In less than 80 meters, the catapults can get an aircraft off the deck in 3 seconds flat. Their power is impressive.
You go from 0 to 300 kilometers per hour in less than 2 seconds. Your head is forced backwards. Fortunately, you have the headrest. You're somewhat blocked during the catapult phase because the acceleration is really remarkable.
The objective of this modernization is ambitious. Flat out, the catapults will be able to launch an aircraft every 30 seconds. A strike force which can only be equaled by the Americans. For the pilots, coordination and trust with the flight deck crew is primordial. While work is being carried out, it's impossible to carry out catapulting and landing exercises on a flight deck, because the Charles de Gaulle is the only French aircraft carrier. Keeping your reflexes tuned is a daily challenge for the pilots and crew on board the aircraft carrier. So how can the pilots stay on form? Paradoxically, this work is carried out on dry land. It's off to the Naval Air Station of Landivisiau in Brittany. This is where the sailors of the sky and deck crews carry on their training. Exercises are performed using lines on the ground which identically reproduce the size and markings of the Charles de Gaulle.
Pilots go through simulated deck landing training. You're on an ordinary runway, but you follow procedures and techniques as though you were on a ship, with a landing officer watching over everything and giving you a score at the end of the practice.
An aircraft carrier in the heart of the Brittany countryside. This is where the sailors go through their maneuvers over and over again.
You keep going over them so you can't make a mistake when you're out on an important mission. It's hard, especially after an 8-hour mission over Iraq. You're exhausted.
But ground training isn't sufficient. To have a system of catapulting and arresting gear, the pilots also need to train on a real aircraft carrier. There's only one possibility. The French military sailors go to practice on an American aircraft carrier.
Cooperation between France and the United States in the domain of aircraft carriers goes back a long way. You should remember that after the Second World War, the Americans lent the French aircraft carriers to increase their know-how.
It's an exceptional trip for the French Navy. After a 6-hour crossing of the Atlantic with in-flight refueling, the Marine Rafales reach the American coast. The entire crew meets up at the Norfolk Naval Station in Virginia.
The aim is to become part of an American Air Force group. Their structures are the same as ours. They have several flotillas. We become one of them.
In all, 350 sailors, 12 Marine Rafales, and 1 Hawkeye make the journey to the United States. It's a unique operation.
If this is already popped when you pull it out, do not use it. On the port side, you want half.
The French Marine Rafale is the only foreign aircraft authorized to land on an American ship.
We're deployed for 2 weeks on board an American aircraft carrier which is dedicated to a Franco-American aviation group. This is important because our interoperability with the Americans is fundamental.
The French pilots will train day and night on the aircraft carrier Bush, alongside F-18s and Hawkeyes of the US Navy. This exceptional operation is highly symbolic. It's a statement of French cooperation with its allies. But the pilots and flight deck crew are not the only ones who need training. The entire crew of the Charles de Gaulle must be ready for combat when the aircraft carrier weighs anchor. Across the oceans of the world, the Charles de Gaulle has to cross extremely troubled zones. To protect the aircraft carrier, the marksmen of the French Navy need to stay at the height of their capacities. Once afloat again, the sailors will need to become familiar with this new generation aircraft carrier as quickly as possible. As work carries on in Toulon, the Navy is already preparing for future conflicts. In this simulator at Toulon Naval Base, artillery training takes place during the work. In order to become accustomed with hostile behavior, this training area is highly immersive.
Oh, Peter, Captain, 2 armed men to starboard, 10 on the jetty.
The screen reproduces the trajectory of fire and weapon movements in real-life conditions.
The path is classed as hostile.
Dangerous situations are rehearsed within a 3D environment projected on the walls of the simulator.
OP to captain, no response to warning. CDG to OP, we've carried out a 3 warning.
Today, the sailors are in a simulation of the Suez Canal. If this situation arises in the field, the best strategies need to be quickly chosen. The challenge is both military and diplomatic. The Charles de Gaulle is a highly political weapon in the hands of the President of the Republic. Any false move could be interpreted as a declaration of war.
So you're right to limit yourselves to that.
The Charles de Gaulle is the flagship of the French Navy. To keep at bay any other ship, aircraft or drone, the aircraft carrier has an exceptional detection system.
The combat system is what allows the ship to be aware of its environment.
To detect any threat, the Charles de Gaulle has an arsenal of 7 radars. These radars are the eyes and ears of the ship. Huge pieces of equipment which need to be modernized and adapted to the future missions of the Charles de Gaulle. For example, the ARBB-33 jammer radars, situated either side of the bridge. They play an essential role. By overloading enemy captors with interference, these jammers make it difficult to calculate the precise position of the Charles de Gaulle. It's a technique designed to outwit enemy radar and certain weapons. In order to protect the French naval forces, the Charles de Gaulle needs to be able to detect any aircraft or missile from over 100 kilometers away.
Reactivity within the force is extremely important, particularly in the face of the most modern threats. I'm thinking, for example, of anti-ship missiles which could be used against it. When you detect this threat, you only have a matter of seconds to react.
Target locked! Target locked!
Within the modernization framework, the new Smart S radar will allow the aircraft carrier to detect any aircraft or drone from over 300 kilometers away. Its detection capabilities are 10 times superior to its predecessor. This precision will be indispensable in conflicts of the future. The future Smart S surveillance radar is set up on the Saint-Mandrier Peninsula, some 15 kilometers from the worksite.
One of the major challenges of this work is to carry out all the modernization over a very limited time span. So one of the ways we limit the time necessary to get accustomed to the new material is to test it out beforehand in places other than the ship itself.
After extensive testing, the radar is ready to be fitted on the Charles de Gaulle. With utmost precision, the technicians of Naval Group detach the new radar from its transportation frame.
There's an axis for removal.
Once strapped to a crane, it's lifted a few centimeters. While it's raised, the technicians check that nothing will become detached. On board the Charles de Gaulle, another group of technicians prepares the base plate, which will receive the radar.
In order to install the radar on the ship, a certain number of constraints and demands need to be respected, in particular related to the connecting surface. The precision of this can be quite impressive, sometimes to within a millimeter or a tenth of a degree.
The radar finally takes up position on the Charles de Gaulle. Once installed, it requires some final adjustments.
The antenna needs to be turned, it needs to be aligned. Mechanical pieces need to be added to limit the amount of play. The electrical connection needs to be made for the motor. The tension needs to be checked to make sure it's correct.
Apart from its technical capacities, this radar brings another considerable advantage to the aircraft carrier.
If you take the last radar, which dates back 30 years, it needed 15 or so bays in order to work. A bay is a huge cupboard stuffed full of electronics. Now, with the new replacement, you need only 2 bays and a small cooling module.
So while the old generation aerial radar took up around 60 to 100 square meters across several decks, we now have one which only needs 20 square meters.
At the moment of landing on the Charles de Gaulle, the pilot is helped by an indispensable piece of equipment, the optical landing system, the device seen to the left of the flight deck. This system works with different colored lights, which act as markers for the pilot during the landing phase. In Toulon, this system has been completely rethought. The previous OLS and its platform have been completely dismantled. A new platform is being installed. It's a delicate operation. This immense red section is extremely heavy, more than 8 tons. It will allow the new optical landing system to be attached. Along with the ever-present landing officers on the flight deck, this is what guides the pilot during landing. A gigantic array of lights send out 2 signals, yellow light from the center and a horizontal row of green lights. These allow the pilots to adjust their trajectory. Once the yellow light is lined up with the green lights, the pilot knows that the approach path is correct for landing. This morning, it's as though Christmas has arrived early. The Naval group technicians unwrap the OLS.
The optical landing system could be compared to a pinball machine with all its lights. There are 2 types of pinball machine, the old American ones from the 1980s with the old lamps and old technology, and the modern pinball machines based on fiber optics, which are much more dependable than before.
Technicians check out the alignment of the luminous signals on the deck of the ship. The instrument needs to be on exactly the right axis to be operational. And it naturally has to be connected to the electronic systems of the aircraft carrier. No less than 4 kilometers of cabling are necessary for this apparatus alone. Not far away, technicians are impatiently awaiting the arrival of a new key element, the laser landing aid. This is a system which allows the flight deck officer to pinpoint the position of aircraft during their final approach phase.
To help with landing, you have an optical system which is based on a laser beam being emitted by the aircraft carrier, reflected by the aircraft, and coming back to the aircraft carrier. It's used to guide 2 cameras, the daytime camera and an infrared nighttime camera.
Meticulously parceled up, the package is set down, gently. The laser is made up of several parts which need to be slotted together, one by one. A highly risky operation performed on outsized Lego. The pieces being manipulated are very precious technological gems. To help with assembly, the surfaces are greased. Hanging from a crane, millimetric precision is called for. In bad weather, landing on the Charles de Gaulle is a difficult operation. Marine Rafale pilots say that viewed from a distance on the high seas, the Charles de Gaulle looks like an underground ticket. Don't forget, of course, that landings also take place at night. This challenge requires sailors to be on call 24 hours a day.
An aircraft carrier sends off and retrieves its aircraft more or less into the wind. This means that the aircraft carrier spends its time doing U-turns, quarter turns. All these evolutions mean that the platform is constantly destabilized, moving around, which vastly complicates work on the flight deck.
One of the difficulties is making sure that the deck is as stable as possible. Stability is all about making the aircraft carrier's deck as steady as you can for the pilot.
To keep the rolling of the flight deck to a minimum, the French have perfected a stabilization system which is unique. This system is composed of three elements: the ailerons, the rudder blades, and the list compensation shuttles. When the ship rolls with the waves, a central calculator coordinates these different parts of the ship. The flight deck is re-leveled in this way to help pilots to land. The Charles de Gaulle is the only aircraft carrier in the world to be fitted with this technology.
With the platform tranquilizing system, and in particular the list compensation shuttles, we managed to achieve an extremely stable platform. From a tactical, an operational, and a practical point of view, this stability of the flight deck is a considerable advantage.
These list compensation shuttles, today hanging from cranes, are essential to the stabilization system. They are very compact trucks running along iron rails. The principle behind these shuttles is revolutionary. 12 shuttle rails span the whole width of the flight deck. Like weights on a pair of scales, these shuttles move to compensate the list of the ship. If the flight deck leans to one side, the shuttles are immediately drawn to the opposite side. In this way, the deck is re-leveled. A total of 144 parts beneath the ship's flight deck. Each section weighs several tons. When the French army is deployed around the world, the Charles de Gaulle is a powerful element of diplomatic leverage. With this huge modernization program, the Charles de Gaulle will continue to draw other naval forces to its side, be they French or from other countries. This military leadership is founded on a central strong point: its nuclear propulsion. During its worldwide sea missions, it's no longer necessary to refuel in order to power the ship, as its predecessors, the Foch and the Clemenceau, needed to.
As a user of the Charles de Gaulle, I greatly appreciate its nuclear propulsion, mainly because it frees up an enormous amount of space because you're not obliged to lug around fuel to power the ship. And when you're sailing at speeds of around 20 knots, about 40 kilometers per hour, you consume a lot of fuel.
On board, you don't need to reserve space for the fuel needed for propulsion because this fuel takes up less than a dozen cubic meters and is sufficient to keep you going for 10 years.
Effectively, the nuclear cores are not inexhaustible. Every 10 years, they need to be completely renewed. And this operation will be carried out during the present overhaul.
The nuclear reactors of the aircraft carrier are there to produce energy in the same way as a battery does. 10 years ago, we set out with batteries charged to 100%, and we didn't have any way of topping them up. When they're down to zero, you need to change the batteries.
It's quite remarkable that we only have to do this every 10 years. To give you a comparison, with the National Grid reactor, the cores need replacing perhaps once a year or every 18 months.
Going back to the 1980s. For the building of the Charles de Gaulle, France chose revolutionary technology: atomic energy. The Charles de Gaulle has 2 nuclear reactors. Each uses atoms of uranium-235. Bombarded in tanks, these atoms produce energy in the form of heat. The energy given off in this way by the nuclear cores is used to heat the water collected in the generators. Raised to extremely high temperature, steam pressure provides power for the ship's propulsion, but also supplies the catapults and numerous onboard systems. The energy produced is astonishing. It could supply a city with 20,000 inhabitants. For recharging the reactors, surveillance in Toulon is maximal. The nuclear cores are extremely sensitive. These French reactors need to be protected against industrial espionage, but the ship also needs to be protected from any potential attack.
We need to be certain that all measures of protection are taken and to make sure there is no aggression either against the ship itself or the onboard personnel or the nuclear boiler.
I can't go into operational details because they're classed as secrets of national defense, but there are extremely high nuclear safety requirements.
Because of the risk of accidents or terrorism, the military provides round-the-clock supervision of the zone during the recharging of the reactors. Only certain certified engineers and workers are allowed access. No cameras are permitted.
This technical operation, which is extremely complicated for the battleship, is carried out within an extremely precise framework. It happens inside the naval base, where there is an additional protection zone around the Charles de Gaulle. Then, in order to access the propulsion or nuclear boiler areas, there are other barriers to pass through before you reach the work site.
Recharging the nuclear cores is an extremely complex task, because the tanks possess various layers of protection. To extract the depleted uranium, the reactors need to be opened, layer by layer.
You can think of it as being a bit like Russian dolls, which need to be opened one after another in order to reach the nuclear core in the last one, so you can take it out and replace it.
This is open-heart surgery, performed against the clock. Because when the Charles de Gaulle is immobilized, an entire section of French defense is weakened. For the entire duration of the overhaul, France has no nuclear aircraft carrier available, so there's no question of falling behind schedule. In a conflict situation, the Charles de Gaulle could be hit at any moment. The sailors need to be able to carry out the safety procedures instinctively should an incident occur. During the overhaul, many areas have been redesignated, whether it be for installing the new communication system or the change to 100% Rafale. In order to adapt to these changes, exercises like this one are carried out.
Fire alarm in Delta 013 post-OM. Evacuation of the zone with A3P mask, recuperating material from the affected zone.
In the case of an explosion or a fire, the Charles de Gaulle in its entirety is threatened. While work is in progress, the safety teams train regularly to fully come to terms with the new layout of the ship. Today, Lieutenant Audrey is in charge of training. Today's exercise, simulation of a fire in the gangways.
The priority is finding out if anyone is still in the zone.
The sailors note down their interventions minute by minute. Nothing must be neglected.
DDL lines, over.
Situation update. We have a casualty.
Alarm. Casualty evacuated at PRV level.
Coordination is continuous. In case of damage or attack upon the Charles de Gaulle, measures need to be taken as quickly as possible.
Beginning attack. PRV level. Beginning attack. Beginning firefight attack.
Delta 017.
Preparing such an emergency evacuation requires unfaltering level-headedness. The Charles de Gaulle has more than 1,000 rooms. It requires in-depth knowledge of this gigantic labyrinth.
Fire extinguished. Fire extinguished.
The fire is under control and the casualty moved to safety. To evacuate a nuclear vessel like the Charles de Gaulle, extensive know-how is called into play. During a potential conflict, the lives of 2,000 sailors are at stake.
We have one casualty evacuated to PRV, forward PZ. The priority is the preserving of human life. End of communication.
Below decks, at the lower levels of the ship, an army of hundreds of sailors is involved in handling the aircraft. But more generally speaking, every sailor on the Charles de Gaulle, from the cook to the doctor, is focused on one objective.
Activities are carried out to the rhythm of the catapults and the enormous vibrations they send through the whole ship. Everybody knows when an aircraft is catapulted, and everybody hears when an aircraft lands.
To get the best out of this high-performance war machine, the sailors all work together like a single person.
You're not necessarily always fully aware of it. But in the back of your mind, you know that you're only there taking this enormous 5G acceleration because of the colossal work of several thousand people.
This is the hangar where the carrier-borne fighters will be sheltered, the flotilla of marine Rafales. The hangar, a huge space situated beneath the flight deck. Engine testing, electronics repairs, it all takes place here. When they return from a mission, this is where the aircraft are repaired. Before this modernization, the carrier-borne flotilla was made up of marine Rafales and super étendards. Naturally, the configuration was quite different because the super étendard has folding wings, unlike those of the Rafale. The workspace needs to be adapted accordingly.
When you put it in a hangar or on the flight deck, it takes up more room, and above all, it's more massive.
Another difference, the Rafale is twin-engined, unlike the super étendard. Consequently, it's no longer one, but two engines which need to be inspected and sometimes even replaced.
When you need to carry out repairs on an aircraft, you need to have room, and you need to get at it relatively easily if you're going to be efficient.
As soon as we're at sea, we'll take advantage of it to check that all elements of the jet engine test beds in the computer system are functional.
Right, okay.
One of the biggest operations has been overhauling the engine workshops to adapt them to the 100% Rafale changeover. Previously, we had to deal with two types of engine, those of the super étendards and those of the Rafales. From now on, it's exclusively about handling the Rafale engine, the M88.
During an intervention inside enemy territory, all aircraft are susceptible to being attacked or having a problem. To change and test the famous Rafale engine, the M88, a huge operating block, has been put in place. It allows the Rafales to be dissected after returning from a mission.
Here we have a cradle dedicated to engine inspection operations. We're lucky enough to have here an M88 engine placed on another maintenance cradle, as you might see in operational conditions.
On the high seas, the Charles de Gaulle is sorely tested. Between temperatures which are tropical or glacial, storms at sea, or in the desert, the installations must be capable of taking a beating. And the new equipment, the latest radars, calculator, fibre optic cables, must be able to resist for the next 20 years. One of the elements which is the most complicated to control is heat. At sea, the temperature generated by all the installations is colossal. To avoid the onboard equipment overheating, the ship is fitted with enormous air coolers. Today, sheet metal workers and welders are cutting through the outer plating in order to remove these air coolers. It's a heavy operation. The Charles de Gaulle has a double hull which is more than a metre thick. Perforated, scratched, deformed, worn by the sea, the Charles de Gaulle's double hull has been mistreated. The hull needs to protect the Charles de Gaulle's new instruments for more than 20 years. 2 decades spent crisscrossing the seas have left their mark on the aircraft carrier. Like a patient in the operating block, the wounds need to be carefully stitched. To protect the new high-tech material, the hull needs to be like new, both outside and inside. This high-precision work is entrusted to specialist welders. In the hull alone, more than 100 holes have been made. Everything needs to be meticulously repaired. Specialist teams are called in to deal with the holes. They check how watertight each section is with the use of X-ray and ultrasound. Each of the repaired holes is X-rayed so that it can be minutely examined.
We make very complex inspections using X-ray, a bit like you would with a broken arm, to eliminate any errors and make the hull as good as new.
Here, the welding of an engine manifold is being inspected.
We check that there are no signs within the weld, such as cracks or porosity. Here, you see the external diameter, here in white, the thickness of the manifold. Here is the weld, and here, the interior of the manifold. The dark part is where it's empty.
Once back in the water, the hull of the Charles de Gaulle must be able to resist all the oceans of the world for the next 2 decades. This overhaul, lasting a total of 18 months, will be over in a few weeks. We're on the home straight. There still remains a highly symbolic stage, putting back in place the Charles de Gaulle's anchors. Connected to the ship by 300-meter mooring lines, these 80-ton giants need to be hoisted without damaging the newly painted hull. While the last dabs of paint are being applied, a meeting is being prepared. The heads of Naval Group are organizing the last stage of work on the Charles de Gaulle in the basin, the refloating.
Today is a normal day, tomorrow we're on 2-8.
The atmosphere is tense. These are the last moments of the aircraft carrier in dry dock.
By nature, a ship docked in a port is more vulnerable. A ship is built to be at sea, particularly a battleship. It's meant to be at sea, to be mobile, to use its sailing capacities, to carry out missions.
The aircraft carrier Charles de Gaulle is unique in France. Stopping it to carry out maintenance operations incurs operational cost, because for 18 months the aircraft carrier is totally unavailable, so it can't intervene where the political powers want it to be.
French defense urgently needs to retrieve its unique nuclear aircraft carrier. The clock is ticking. Lack of concentration on the part of one laborer or sailor could delay the ship's departure. To avoid any hiccups, Jean-Nicolas, the head of refloating operations for the basin, verifies that everyone has in mind all the elements of the day's maneuvers. Everything has been planned down to the last detail.
That's it. Have a good day.
For maximum safety, the basin needs to be filled by degrees in order to ensure that the hull is watertight. It will take 48 hours. The first stage will immerse the ship to a depth of 1 meter. The following morning to 3 meters 80. The afternoon, 5 meters 80. Then a fourth stage the following day to 7 meters 60. The last level before totally refloating and undocking. During the partial refloating, the Charles de Gaulle remains connected to land.
Our objective is to choose the moment for refloating the ship. Theoretically, Wednesday evening. Then there's no going back.
The aim of the maneuver is to check that there are no leaks. Everything depends on flexible supply tubes.
All the supply tubes are connected. They allow us to begin flooding the dock with seawater. All the tubes will stay connected during the partial refloating.
It's only at the 4th level that the supply tubes will be disconnected from the ship.
It's a safety margin which guarantees that the ship remains standing on its key blocks. It allows us to keep the ship standing, but at the same time, everything is functional on board.
Once the flooding has begun, there's no going back. At their posts, the Naval group technicians hold their breath. The flooding begins. A torrent of seawater fills the basin at incredible speed. To undock the monumental weight of the aircraft carrier will require filling the equivalent of 47 Olympic-sized swimming pools.
I'll call you back for the closing of the basin.
It's the big day. The basin is full. The Charles de Gaulle still needs to be guided out of port.
Come on, guys, onto the quay. I'll call the naval base.
French Navy divers are on hand to remove the last mooring ropes.
Have you dived into the spacer? Yes. What about at the back?
They're in permanent communication with the Naval group technicians. Huge protectors are in place. During undocking, the hull mustn't be allowed to scrape the concrete quay. The success of all the work is at stake. For this final stage, sailors, soldiers, laborers, and exterior technicians work hand in hand. Then, once on the water, the Navy will take back total control over the aircraft carrier.
A guy from the Charles de Gaulle with one of my guys. We spread out over the entire ship, 4 at the back, and 5 others with me. There are 5 of you. Perfect. Do what you have to. You've never done it? You go with him, and you two with him, and we'll work it out little by little.
The sailors are taking back possession of their ship. On the embarkation areas, in the maneuver zones, and on the gangplanks. The captain and the entire crew take back command of the ship. They direct the maneuver and correct any eventual drifting. To all DRPs beginning movement. It's a symbolic stage, but it's just the beginning of the next part of the operation. We can begin the sea trials, the floating trials, and head towards the end of the technical shutdown.
The Charles de Gaulle, back in the water, is like a patient leaving a hospital. It's a sort of resurrection, back to the natural environment.
Over long months, every element of the ship has been explored. Nuclear boilers, stabilization system, optical landing system, Rafale's catapulting mechanism, military radars, propulsion system, but also the hangar and the CIC, the nerve center of the aircraft carrier. Over 18 months, the Charles de Gaulle has been revised from top to bottom, and this gigantic overhaul has mobilized skills all over France. Brest, Nantes, Angoulême, Lorient, Cherbourg, Toulon. Thousands of specialists have been called upon to carry through this work. In Brittany, as well as in the United States, the Rafale pilots of the Navy have prepared their return to the aircraft carrier. After 5 years of preparation, then 18 months' work, the biggest work site in France comes to an end. Conceived at the end of the 1980s, the Charles de Gaulle has had a complete makeover, a unique technological achievement. New life has been breathed into this legendary ship, With this exceptional modernization, French defense is ready to enter a new era, that of the 21st century and the conflicts of tomorrow.